The woman who saved the Spitfire. The year was 1940. Britain stood alone. The German Luftwaffe dominated the skies of Europe. And every day, the Royal Air Force sent its young pilots into deadly battles they were never sure to return from. Above the white cliffs of Dover, in roaring engines and screaming metal, the fate of Britain's freedom was being decided. At the heart of that struggle was one aircraft, the Supermarine Spitfire, a sleek, fast, and elegant fighter that symbolized hope for the nation. But behind the glory, a dark problem was emerging. Spitfires were being lost not from enemy bullets, but from mysterious engine failures. Engines would suddenly seize mid-flight, causing the aircraft to stall and crash. Pilots called it the curse of the Merlin. Inside the factories where thousands of aircraft were being assembled, engineers were working day and night. Each part was critical, each mistake fatal, but no one could explain why so many engines were failing. Then came one woman, an engineer whose name history nearly forgot. She wasn't a general. She wasn't even supposed to make design changes. But what she noticed would change everything. While inspecting the engine mounts of a Spitfire, she found something small, almost invisible. The mounting bolts vibrated too much during flight, creating tiny misalignments that caused friction inside the powerful Rolls-Royce Merlin engine. Her solution? A metal washer, small, round, and worth barely 50 cents. She placed the washer between two key components to absorb the vibration. No one had asked her to do it. No one believed it would matter. But she trusted her instinct and risked her job to make the change anyway. When the next Spitfires rolled out with her washer installed, the results were immediate and astonishing. Engine failures that had crippled the Air Force dropped from 38% to 0.4%. In just 1 month, pilots noticed it first. Their engines no longer shook mid-flight. The aircraft felt smoother, stronger, almost alive. For the first time in months, they could fight the Luftwaffe on equal terms. That 50-cent washer would go on to save more than 2,100 pilots, and perhaps the reputation of the Spitfire itself. It was a reminder that sometimes history is changed not by great leaders or mighty weapons, but by ordinary people with extraordinary ideas. The secret that saved the skies. News of the mysterious improvement spread quietly at first. In the busy factories of wartime Britain, no one had time for miracles. Only results mattered. Yet, mechanics began to notice. The Spitfires, coming from one assembly line, were performing far better than the rest. Engines that once overheated ran smoothly now. Maintenance crews, who used to spend sleepless nights replacing broken parts, suddenly had little to repair. Something had changed. Something small, but powerful. Supervisors grew suspicious. They inspected every modification, every bolt, every piece of metal. And then they saw it, that tiny washer, placed exactly where no official design had called for one. When asked who authorized it, the woman engineer simply replied, "No one. I just wanted our boys to come home." At first, her boldness caused outrage among senior engineers. No one was supposed to alter a government-approved design during wartime production. But when the data came in, showing a dramatic drop in engine failures across all test flights, their anger turned into stunned silence. The Air Ministry ordered immediate testing. Squadron after squadron confirmed the same result. The modified Spitfires could climb faster, turn tighter, and fly longer without mechanical issues. By September 1940, Britain faced its darkest hour. The Battle of Britain had begun. German bombers crossed the Channel daily, escorted by deadly Messerschmitt Bf-109s. Every Spitfire that stayed in the air meant one more chance to defend the nation. Thanks to her 50-cent fix, the RAF could now send pilots into combat with full confidence. The Spitfire, once plagued by unreliable engines, became a legend of engineering perfection. It outmaneuvered every Bf-109 in the sky, earning its place as the fighter that turned the tide of war. And yet, the woman who made it possible remained unknown to most. Her name never appeared in official reports. Her idea, a simple metal washer, was quietly added to every new Spitfire without fanfare or credit. But among the pilots, a whisper spread. Someone out there saved us. And she did it for 50 cents. The unsung engineer, how a tiny washer helped win the Battle of Britain. Summer, 1940. The skies over southern England roared with the thunder of war. Every day, hundreds of RAF, Spitfires and Hurricanes scrambled to intercept waves of German bombers and Messerschmitt Bf-109s crossing the Channel. Britain's survival depended on its pilots and their machines. But in the shadows of that desperate struggle stood thousands of engineers, mechanics, and factory workers, quietly fighting their own battle. The battle to keep those machines alive. Among them was one woman, whose sharp eyes and determination would change history forever. Her name was Beatrice Shilling, a British engineer whose brilliance went far beyond what her superiors expected from a woman in a man's field. She had joined the Royal Aircraft establishment as a technical specialist, and when she saw a problem, she solved it. At the time, the Spitfire's Rolls-Royce Merlin engine was a masterpiece, but also a fragile one. During steep dives, the engine's carburetor would flood with fuel, choking the engine and causing it to fail mid-battle. Pilots were forced to level out before diving again, giving the German Bf-109s, with their superior fuel-injected engines, a deadly advantage. It was then that Shilling's discovery became a turning point. She designed and installed a simple metal washer, a small restrictor plate fitted inside the carburetor's fuel line. This washer, later nicknamed Miss Shilling's Orifice, by RAF pilots, regulated the fuel flow perfectly, preventing the engine from flooding during combat maneuvers. The part cost less than 50 cents, but its impact was beyond calculation. Once fitted, the Merlin engine could now dive and climb with flawless control, giving British pilots the edge they desperately needed. By the spring of 1941, every Spitfire and Hurricane in active service had her device installed. Pilots instantly noticed the change. In dogfights above London, over Dover, and across the fields of Kent, the Spitfire's engine screamed with new life. For the first time, the RAF could outturn, outdive, and outlast the Luftwaffe. The British pilot's survival rate soared. Many who might have perished returned home, because one engineer refused to accept failure. Despite her immense contribution, Shilling never sought fame or reward. When asked about her invention years later, she simply said, "It was my duty to make sure our boys had the best chance possible." Her washer, small and simple, became a legend among pilots, a reminder that behind every victory, there are countless unseen heroes. While generals planned and pilots fought, it was the quiet courage of people like Shilling that kept the engines of freedom running. And in the roar of every Spitfire that soared through the clouds, there was a whisper, the sound of a 50-cent washer doing its job, saving lives. The legacy that took flight. By early 1941, the balance of air power had begun to shift. The once invincible Luftwaffe, which had dominated Europe's skies for years, was now facing something it hadn't seen before. A British fighter that could match its speed, outclimb its rivals, and fight with unbreakable endurance. That fighter was the Supermarine Spitfire, powered by the Rolls-Royce Merlin engine, and perfected by one woman's brilliance, Beatrice Shilling. Her tiny metal washer, no larger than a coin, had transformed the fate of the RAF. Engineers across Britain called it the fix that saved the Spitfire. Pilots called it something else, the guardian in the engine. But Tilly's contribution didn't stop at Britain's shores. As the war expanded, the Merlin engine became the beating heart of several legendary Allied aircraft, the Hawker Hurricane, the de Havilland Mosquito, and even the mighty P-51 Mustang of the United States Army Air Forces. When American engineers began fitting Merlin engines into the Mustang, they also included Shilling's modification. The result was extraordinary. The P-51D Mustang, with its modified fuel system, could now fly faster, higher, and farther than any fighter of its generation. That same 50-cent idea, born in a small British lab, was now helping the Allies dominate the skies over France, Germany, and the Pacific. Every time a Mustang escorted bombers deep into enemy territory, Tilly Shilling's legacy flew with them. Back in Britain, she continued her work quietly, fusing public recognition. While newspapers praised fighter aces and generals, few even knew her name. But among the engineers at the Royal Aircraft Establishment, she was revered not just for her mind, but for her courage. During the war, women in engineering were often dismissed, doubted, or ignored. Yet Shilling stood firm, demanding precision, respect, and results. She earned her pilot's license, rode powerful motorcycles, and lived by her own rules, a pioneer in every sense. When the war finally ended in 1945, thousands of pilots owed their lives to her. Yet, in her modest way, she simply moved on to new challenges: jet engines, testing facilities, and advanced aerodynamics. Still, her invention remained a quiet symbol of wartime ingenuity, proof that even the smallest part, in the right hands, can change the course of history. Years later, one surviving Spitfire pilot said in an interview, "We used to joke that Miss Shilling's washer was worth more than gold. Without it, many of us would never have made it back." Her story reminds the world that true heroism doesn't always wear a uniform or carry a weapon. Sometimes, it wears a lab coat and holds a tiny piece of metal that saves thousands of lives. After the war, the woman who engineered the future. When the guns of Europe finally fell silent in May 1945, the world began to rebuild. Cities lay in ruins, nations were exhausted, and the heroes of war, soldiers, pilots, and civilians alike, tried to find their place in peace. Among them was Beatrice, Tilly Shilling, the woman whose quiet invention had changed the course of air combat. While the world celebrated victory, she returned to her workshop at the Royal Aircraft Establishment in Farnborough, doing what she always loved: solving problems no one else could. To most, she was the lady who saved the Spitfire. To her colleagues, she was a relentless mind, practical, precise, and utterly fearless. A new era of flight. The war had ended, but a new kind of race had begun, the race for speed, altitude, and the age of jet propulsion. Britain, America, and the Soviet Union were now testing aircraft that could shatter the sound barrier, and once again, Shilling's expertise became invaluable. She helped design high-speed fuel systems and testing equipment for jet engines, ensuring safety and efficiency in an era when aircraft could reach unimaginable speeds. Her engineering philosophy never changed. Every small detail mattered. Tilly's contributions shaped the birth of modern aviation technology. From turbojets to pressurized flight systems, her methods and principles became part of every aircraft blueprint that followed, breaking barriers beyond the sky. But Shilling's influence was not limited to machines. She also helped break the barriers of gender in science and engineering. At a time when women were often pushed back into domestic roles after the war, she refused to step aside. She continued working in research, became one of Britain's first female senior engineers, and mentored younger women entering the field. When asked how she managed to succeed in a world dominated by men, she famously replied, "You don't ask for permission to be brilliant, you just get on with it." Her courage inspired a new generation of women scientists, engineers, and pilots, those who would later design spacecraft, rockets, and supersonic jets. The last flight. In her later years, Beatrice Shilling remained as spirited as ever. She raced motorcycles well into her 50s, loved speed in all forms, and never lost the curiosity that defined her life. When she passed away in 1990, she left behind more than inventions. She left a legacy of determination, creativity, and equality. Historians now recognize her as one of the great unsung heroes of the Second World War, not because she commanded armies or flew missions, but because her intelligence saved those who did. From the engine roar of a Spitfire to the silent glide of a modern jetliner, her spirit lives on, a reminder that greatness often begins with something small, perhaps no bigger than a 50-cent washer. Rediscovering a forgotten genius. For decades after the war, Beatrice Tilly Shilling's name was known only in whispers in workshops, in engineering schools, and among the few surviving Spitfire pilots who still remembered the miracle fix. While historians wrote volumes about the Battle of Britain, her contribution, the simple metal washer that saved over 2,000 pilots, remained hidden beneath the noise of medals, glory, and military reports. It wasn't malice. It was just the way history often forgets the quiet heroes, the thinkers behind the machines. The rediscovery. In the late 20th century, as aviation historians began re-examining wartime records, they noticed an anomaly. A sudden drop in Merlin engine failures during the summer of 1940. The technical logs mentioned an orifice restrictor, installed by order of the Royal Aircraft Establishment, but gave no credit to the person who designed it. That's when researchers uncovered the truth. The device had been the work of Tilly Shilling, an engineer who defied the rules, ignored bureaucracy, and changed history with a part no bigger than a coin. Soon, her story began to appear in books, documentaries, and academic papers. She was no longer a footnote, she became a symbol of intellect under pressure, a reminder that in war, brains often matter more than bullets. Honoring her legacy. By the 2000s, museums across Britain began honoring her work. The Royal Air Force Museum, Imperial War Museum, and Science Museum of London all featured her contributions. Her invention, nicknamed Miss Shilling's Orifice, was displayed alongside the Spitfire's legendary Merlin engine, a tribute to the mind that made the machine unstoppable. In 2009, the Institution of Mechanical Engineers added her name to their Hall of Fame, recognizing her as one of Britain's most important wartime innovators. Modern RAF engineers still mention her story to young recruits, a lesson in humility, precision, and courage. They remind them that the smallest part, when crafted with care, can change the outcome of a war, inspiring the future. Today, Tilly Shilling's life is taught not only in aviation history, but also in STEM programs around the world. She is celebrated as a pioneer for women in engineering, a figure who proved that intellect knows no gender, and that determination can rewrite destiny. Her story has inspired scholarships, awards, and mentorship programs for young women entering science and technology. Each year, at Farnborough, where she once worked, students gather to hear her story and see her original tools, still preserved, still shining. The lasting echo. 80 years after the Battle of Britain, when a restored Spitfire takes off into the sky, the engine still carries her fingerprint. The soft hum of the Merlin, steady, powerful, alive, is her silent legacy. The Spitfire to the stars, the enduring legacy of Tilly Shilling. The world had changed beyond recognition since the days when the Spitfire ruled the skies. The engines had grown louder, faster, and hotter. Propellers gave way to jet turbines, and the sound of piston engines was replaced by the roar of supersonic flight. But deep inside those new machines, in the blueprints, in the principles of fuel control and vibration balance, lived the legacy of one woman, Beatrice Tilly Shilling. The jet age awakens. In the 1950s, engineers at Rolls-Royce, de Havilland, and Bristol were developing aircraft that could fly faster than sound. The Gloucester Meteor, English Electric Lightning, and later the Concorde, all relied on precision fuel systems that echoed Shilling's philosophy: control the flow, control the power. Her work on carburetor restrictors during the war became the foundation for jet fuel metering systems, critical for high-altitude flight stability. What began as a 50-cent washer in a Merlin engine had evolved into the logic that powered an entire generation of jet aircraft. Even earliest space program engineers studied the same balance of pressure and fuel regulation she perfected. The same physics that governed a Spitfire's dive now governed a rocket's ascent. Engineering principles that shaped the future. Tilly believed that the key to good engineering was simplicity married to precision. Every part, no matter how small, had a purpose. She often told young engineers, if a solution is too complicated to explain, it's not a solution, it's a mistake. This mindset shaped post-war aerospace design across Britain, America, and Europe. Her approach influenced everything from jet fuel regulators to liquid rocket injectors, the very systems that would later send satellites and astronauts into orbit. By the 1960s, her techniques were cited in engineering, manuals, and technical colleges around the world. Few students knew her name, but they were studying her ideas, the hidden line to the future. When NASA engineers were testing the early rocket engines of the Mercury and Apollo programs, many of their design notes included similar restrictor logic to control flow, stability, the same mechanical principle Shilling had used decades earlier. She had unknowingly planted seeds for the space age. And while men like von Braun or Whittle became household names, Tilly's quiet brilliance flowed invisibly through the veins of every advanced machine that came after her. Her influence wasn't only technical, it was philosophical. She showed generations of scientists that innovation doesn't always come from billion-dollar labs, but from the courage to look at a problem differently. The immortal lesson. Today, every pilot, every engineer, every mechanic who works on an aircraft benefits from what she proved in 1940, that a single overlooked detail can change the balance between failure and flight.